Lesson 108, similar solids. Let's recap what similar means. Number one, the angles have to be identical. So if this is 30 degrees, this is 30 degrees. If that's 90, that's 90. Equal angles, but their sides have a scale factor. In other words, the shapes themselves are not the same size. Now a solid is like this. It's something that has volume. So this is a solid, a triangular prism. So we're going to look at these today. I've got two similar triangles here. Let's say this has a side length of 1 and this has a side length of 3. So the ratio of their dimensions is 1 to 3. Or in other words, it has a scale factor of 3. This is 3 times larger than that. But the ratio of their areas, the surface area, you're going to square both of those, so it's going to be 1 to 9. In other words, the space on the inside of this triangle is 9 times more than the space on the inside of this triangle. Here is another way to think of it, because this is written in ratio form. For every 1 square inch in this triangle, there are 9 square inches in that triangle. Okay, popping back up into here. If I turn these into 3-dimensional shapes, what's the ratio of their volumes? Well, you take the scale factor and you raise it to the power of 3. So the ratio is going to be 1 to 27. For every 1 cubic inch, it's a terrible drawing, in this shape, there's going to be 27 cubic inches in the shape over there. An architect builds a scale model of a building she is designing. The scale of the model is 1 inch equals 5 feet. Now, because the scale is 1 inch is equal to 5 feet, we need to turn them both into the same units. So I'm going to rewrite that as 1 inch is equal to 60 inches. So on the scale building, 1 inch represents 60 inches on the actual building. So the scale factor is 60. Therefore, the surface area of the building is how many times larger than the surface area of the model? Well, if this is the scale factor, how do we find surface area? Square it. So 60 to the power of 2 is going to be 3,600 times greater. So for every 1 square inch on the model, that's going to represent 3,600 square inches on the actual building. All right, so the volume of the building is how many times the volume of the model. So we're going to take our scale factor and raise it to the power of 3 because it's volume. So 60 to the power of 3 is 216,000. So the actual building is 216,000 times larger in space, in volume, than the model is. Try this one on your own. So the scale factor is 10 times larger, so 10 times. How much bronze is needed to make the new statue? Well, the question is this going to be area or volume? We're going to assume it's volume because all the bronze needed to make the statue to fill it all up. So we're going to take the scale factor and raise it to the power of 3. So 10 to the power of 3 is 1,000. And therefore the sculptor is going to need 1,000 times as much bronze to make the new statue as he used for the model statue. I'm going to give you a second, look this over, and then we'll work through it together. The first thing I'm going to do is determine the scale factor. So it's going to be 10 over 6, which seems strange, but you work backwards. So 10 over 6, and I'm going to reduce that to 5 over 3. I'm going to leave it like this in fraction form, so the scale factor is 5/3. So in other words, this is 5/3 times larger than this. Okay, if the surface area of the small cylinder is 30 pi meters squared, 30 pi meters squared, what's the surface area of the larger cylinder? Notice you do not have enough information to just find it using the surface area formula because there's no radius. What we have to use is the scale factor. So here's the scale factor, but because we're dealing with area, what are we going to do with this? Raise it to the power of 2 because area is squared. So we're going to do 5/3 squared. Now this is going to be 5 to the power of 2, which is equal to 25. And this is going to be 3 to the power of 2, which is 9. And so the surface area of this cylinder is 25/9 larger than this. So now I'm going to take the area of this guy and multiply it by 25/9. It's up to you to determine how you want to simplify this. You can cross-reduce. I'm going to cross-reduce. These have a common factor of 3. That becomes that becomes that. And now this becomes 250 pi over 3, which I'm going to allow you to leave in this form. But don't forget units. We've got meters squared. So this is the surface area of our big cylinder. Pause the video. Try this on your own. Find the scale factor first. It's going to be 7 over 5. This is the scale factor. It does not reduce, so we have to leave it alone. Now, I'm finding the surface area of both of these. The smaller one has 50 square inches. So what's the surface area of the larger one? Well, I'm going to take my scale factor and raise it to the power of 2. So 7 squared is 49. 5 squared is 25. So the surface area of this shape is 49/25 times larger than this guy right there. Let's calculate the product of those two. Again, I recommend that you cross-reduce here. So this is going to become a 2. This becomes a 1. 49 times 2. So the surface area of this guy here is 98 inches squared. Pause, try it. All right, the scale is 1 to 3. In other words, the scale factor is 3. So the new present has dimensions 3 times larger. If we're going to wrap the present, that's going to be surface area to cover the present with wrapping paper. So we're going to take the scale factor and square it. So the amount of wrapping paper needed now is 9 times more than we needed the first time. So the question says, how much more wrapping paper is needed to wrap the larger present? Well, 9 times more wrapping paper for the new present. All right, the scale is 1 to 9, therefore the scale factor is 9 times larger. What fraction, this is an interesting question. It says, what fraction is the model car surface area to the actual car area? Well, if this is the scale factor, we're going to take this and square it, which is 81. So the surface area of the actual car is 81 times more than the model car. But the question asks, what fraction is the model surface area to the actual car? So that means that for every 1 square inch on the model car, the actual car has 81 square inches. That is our final answer. You've got a quiz tomorrow. But right now, your assignment is lesson 108, A through Z. I'll put the questions up.